We're going to be using the trig functions, SOH CAH TOA, in order to find the sides of right triangles. Now in this case, we need to have one of the angles known on the inside besides the 90-degree angle, and we need to know one of the sides on the outside. There's going to be two sides usually that are going to be missing. In this case, we're going to be solving for x. We are going to use a calculator, and we got to make sure our mode on the calculator is set to degree, not radians. Classic and math print, those two are optional, but degree is mandatory. Now, in this case, just like the previous notes, we need to identify our h, our o, and the a, the hypotenuse, the opposite, and the adjacent. Now here, the 30 is going to be the hypotenuse, so that's our h. Here's our angle of reference, 20 degrees. So x is the o, and then our a is the blank section here. Now, what does make it a lot easier to understand which symbol you're going to need is you could use a highlighter. It's optional. But our 30 here has an h, and our x here has the o, which represents the hypotenuse. In this case, we need to use the o and the h, and the o and the h uses s, which is sine. So therefore, we need to put the degree of 20 inside the sine. Now, the order does matter of how the problem is set up. It is always going to be o over h. So in this case, it's going to be x over 30. Now we need to isolate the variable. We're trying to solve for x to find what is the measurement of this side here. Well, I need to get rid of the 30, so we're going to multiply both sides by 30. And then we get 30 times sine of 20. It's going to be the measurement of x. So now we can just put that in the calculator here. 30. You don't need to put the time symbol, but if you feel more comfortable, that's perfectly fine. Sine of 20 on the inside, close that parentheses, and we get 10.260. We're just going to write the three numbers after the decimal without rounding. 260 equals x. And that is the solution for this side here. Let's move this up to a second example here. Now this time I'm going to use 30 on the inside here. I'm going to use 5 for this side, and this time we're going to have x located in this location. We're still going to label our h, our o, and the a. X is the h, and opposite of the 30 degrees is our 5 here, so that's our o. Now I don't need to do a here because I know it's the blank side, because I already have my h, and I have the o. So again, I'm going to be using sine. So sine 30, the order matters, o over h. In this case, o is 5, and h is x. Now the problem on this one is that the x is on the bottom instead of being on the top. When it's on the top, it's usually going to be a little bit easier to do. We still do the same process. I'm trying to isolate the x. So I need to multiply both sides by x right now, because x is in the denominator and it needs to be located in the numerator. Then I need to still get the x by itself, so I need to get rid of the sign. And when I get rid of the sign, it needs to be the entire value. So sine 30, and then divide by sine 30. Now I'm going to get x equals 5 over sine 30. Put this in the calculator. Now, just to show you, right now I'm in math print. So when I put this in the calculator, 5 divided by sine 30 gives me exactly a 10. However, depending on what kind of solution you're trying to have, is going to determine what kind of answer you're going to have. So if you want to have an exact answer, you're going to want to use math print. However, if you have to deal with rounding, that's when classic is necessary. For the most part, classic would be fine, but when you get an entire full number like we did on this one, we ended up getting 10, then it doesn't matter because it's a full value. So here's our third example. I'm going to use 60 on the inside here. I'm going to have X in this location, and we're going to have 25 on this one here. First things first, I want to label. Well, the hypotenuse is across the 90 degrees, so nothing here. Opposite of the 60 is the X, so that's the O. And adjacent is going to be the 25. So I'm using O and A. O and A is going to be TOA. So that means we need tan for this problem. So we're going to have tan of 60 degrees. The order matters. It's O over A. So it's going to be X over, in this case, 25. And when the X is on the numerator again, this is the easier example because we just need to multiply, in this case, by 25 to both sides. And that gets our variable to be by itself. Now, for my solution, it's just going to be 25 times tan of 60. 25 tan of 60. Notice I got a radical here. So if I don't want a radical and I need an exact, a rounded answer, which is a decimal, then I need to change this back to classic. 25 tan of 60, and I get 43.301. So what's going to determine if your calculator is going to be on classic or mass print is determined by the question. Do they want a rounded answer? That means decimal. Or if they want an exact answer, then we need to go back to mass print. So let's make a little note right there. CP, let's just double check our solution again. 25 radical free. But just make a note here saying this one was when we were using classic, and this answer, the radical answer, is when we're using mass print. So these are what the two different modes do on the calculator. Let's do one more example. Still dealing with 90-degree triangles. I'm going to use 10 degrees. I'm going to use 35 and X right here. Last one. Across the 90 degree is the hypotenuse, H. Opposite of the 10 degrees is O. Therefore, 35 is our A. H is cosine. A is 35. H is X. X is located in the bottom, so multiply both sides by X. In order to solve for X, divide both sides by cosine 10. We put this in the calculator now. 35 divided by, and we're dividing because the cosine is located in the bottom in the denominator. 35.53. 35.539. If you need to watch the video again, that's perfectly fine. Leave a like. See you all around.